Next we'll be taking up the bubble sort. So for the same array we had earlier for the selection sort. So as far as code is concerned, that is written here. So before going into the code, what is the difference between bubble sort and the selection sort, or the procedures they use or they offer to sort array? So in case of selection sort, as we just saw, we compare this cell with all other values, right? So this one was compared with 4, then this one was compared with 5, this one was compared with 2, and so on. Here in case of bubble sort, what we do is that we compare two subsequent elements and do the swapping if one is greater than the other, as you'd be seeing with respect to the code in a short while, right? So here 1 would be compared with 4, no swapping would take place. Then 4 would be compared with 5, no swapping would take place, right? Because 4 is smaller than 5. Then 5 would be compared with what? 2, and swapping would take place. So 5 would go here and 2 would come here. Next 5 would be compared with 3. Since 5 is greater than 3, 5 would be going to this place and 3 would be coming to this place. So as against the selection sort, wherein we sorted the 0th cell first, here 4th or the last cell would be sorted first with the biggest or the largest value. Of course, we are again talking with reference to the ascending sort, where we should have the greatest element at the greatest index, or the array location with the greatest index. So greatest index here is 4. So the element there is needed to be the largest among these elements. So that we just saw how this 5 trickled down places to this place so as to sort this last position. So as you can guess, now we'll be starting again with this, comparing with this cell, this with this with this, and we'll be going only up to this position because this cell has been sorted previously, right? So in the pass 2, this cell would be sorted. So next pass would be only going up to this place because these two cells were already sorted, as would be just seeing, right? So if you can just go through the code. So we are starting I loop from 0 and going up to 3, right? What is n minus 1? N is total number of elements, which is 5. 5 minus 1 is 4. 4 less than 4 means 3, right? So for j, so why is this I less than n minus 1? That we have already seen in case of selection sort, so no need to discuss it again. So logic would be the same, but there is a change in case of j loop. So when j is equal to 0, j less than n minus I minus I. So say we just discussed that when we are comparing the subsequent elements for the first time, that means 1 with this, 4, this with this with this with this, we are going right up to what cell? The last cell. So for that pass we will have j, or j should go to what? N is 5. 5 minus I is 0, of course, for the first pass. So 5 minus 0 is 5, minus 1 is 4. What is less than 4? Less than 4 is 3. That means you would be going right up to this place, right? So as far as comparison is concerned, we will be comparing if ARRJ is greater than ARRJ plus 1. So if j is, for example, 0, we are comparing 0th cell with 1th cell. Then if j is, for example, 2, ARR2 would be compared with ARR3. ARR is this area, of course, right? Right? And in that case, for this comparison, when it is true, swapping would take place. So let us do a bit of hand simulation. So when j is equal to 0, right, what is j plus 1? J plus 1 is going to be 1. So what is ARRJ? ARRJ is this, ARR0, that is 1. It would be compared with 4. No swapping would take place because 1 is not greater than 4. So j would be taking the next value with by virtue of this j plus plus, right? So of course j plus 1 would be 2. Now 4 would be compared with 5. That means this and this would be compared, and again no comparison would or the swapping would take place. Next value of j would be 2 and j plus 1 would be 3, and the elements 5 and 2 would be compared. As you can guess, 2 would come here and 5 would go there. right? Next, j would be taking up the value of 3, and of course j plus 1 would be 4, and the elements of 5 and 3 would be given. Is 5 greater than 3? Is 5 greater than, yes, swapping would take place. 3 would come here and 5 would go there. So this is all the values that j is going to be taking when I is equal to 0. So you can see here that the largest element has trickled down to the greatest index, or the cell with the greatest index, or the last cell, we can say, right? Now as we discussed earlier also, it would be against comparing things, or starting the comparison process from the 0th cell itself, and subsequent cells would be again compared, and the process should go on to this point only, which should not touch this cell because it is already sorted. That is why we were discussing a few moments back that what values of I and what values of j are permissible. So for pass 1, the highest value that j could have taken is 3. Why 3? Why not 4? Because we are comparing with j plus 1. So we should leave room for j plus 1 to be within bounds. So if j is equal to 3, j plus 1 would be 4. That is the max we can go as far as j index, or the index in general for this array, is concerned, right? If for example we have a value of j is equal to 4, then j plus 1 would point to 5, which is not a valid index as far as this array is concerned, right? That is why I was saying, so you will have to hand simulate yourself as to how I am going to remain without bounds. So j here, in case of the first pass when I is equal to 0, j should be 5 minus 1. 5 minus 0 minus 1, that is 5 minus 1, that is 4. Less than 4 means 3, right? So it would go 3, so that j plus 1 could go to 4, one index ahead, right? So for other, so having done this pass, j would now take the next value. In fact, I would be taking up the next value, which is 1, and j would again start with 0, right? So this is the value, this 0 is the value of j, but of course this time I would be 1. Why I'm not mentioning I here? Because we don't need it, right? We need j plus 1, but of course I is needed to keep track of the passes. We need to sort this array, but the bulk of comparison would be taken care of by the j loop itself, right? So when I is equal to 1, that means this pass that we have started now, j would start from 0, and of course j plus 1 would be 1. We would be comparing what? 1 and 4. No comparison would take place. Then j would be 1, j plus 1 would be 2, and 4 and 2 would be compared. What should happen? Yes, 2 would come here, 4 would go here, right? Now j would be 2 and j plus 1 would be 3, 4 and 3 would be compared, 4 would go here, 3 would come here. The last value that this pass would allow j to take is 3, so this would be 4, right? So 4 would be compared with 5, right? In fact, this iteration, if you go by this logic, it won't be needed. Why? Because 4 and 5 comparison is not needed, because of course if it runs, it would come out to be true because 4 is not greater than 5. But with respect to the discussion that we were doing till now, is that this 5 or this cell is already sorted, so we should have gone up to this place only. But having seen this pass, and here we can see that this 4 has trickled down from whatever place to this place, that is the next greatest value has come to the next greatest index, or the array element with the next greatest index, which is 3. Of course this 5 was the topmost element. Now the next topmost element, or the greatest element, has come to this place, right? So we have sorted these two cells. Now what remains is that we should sort. Now we should go now from this position up to here, up to 3, and do the comparisons. So if we can do it without animations and all, but as you guessed it right, we have already sorted this array, right? Because there is 1, there is 2, there is 3, and 4 and 5 were already sorted. This much you have invariably sorted this. But if the comparison would have to take place, or this j loop would go ahead, or this I loop would go ahead, I would now be what? 2 and j would again start with 0, right? So I'll be comparing this one with this 2, no change would take place. This 2 with this 3, no change would take place, right? So that is it. We have sorted another array. Next time only one comparison would take place. That means when I would take its next element, 3, right? I would be 3. So I would be comparing j0 and j0 plus 1. That means this element with this element. We won't touch the elements above 2 because they are already sorted by the previous passes. So 1 and 2 comparison won't yield anything. No swapping would take place because they are already sorted, or 1 is not greater than 2. So that is